Okay, the next step in our endowment problem exercises will be to generalize the budget constraint. And it's pretty easy, but it takes a while to get used to the notation, okay? So we're going to imagine that our consumer is endowed with omega 1 amount of good 1, omega 2 amount of good 2, okay? And they spend P1 and P2 per unit on goods 1 and 2 respectively. Okay, and they're going to have some utility function, and for the moment let's suppose that u of x1 x2 equals x1 squared x2. Okay, so given this information, you could be asked to find the utility maximizing amount of x1 and x2 in terms of parameters p1, p2, omega 1, omega 2. Okay, if we generalize the utility function, we could have alphas and betas in there as well. So how do we set this up? We have to apply what we learned in the specific numerical problems, and namely that is we're going to monetize or value this omega 1, omega 2 endowment by multiplying P1 by omega 1, adding it to P2 omega 2. So this is the value of, or the potential value of the endowment. Okay? And that's going to have to equal the expenditures, P1 x1 plus P2 x2. Okay? So we can think about this at the moment as income. Okay? Because we can think about this as income, see, we can't really control omega 1 or P1, omega 2 or P2, we can employ the Cobb-Douglas rule that we learned before, and we can jump straight to a solution for the optimal amounts of x1 and x2. So we would know that x1 star in this case would be 2 over 2 plus 1, that's 2/3, times m, well there is no m, but this is our m equivalent in the problem. So we would have P1 omega 1 plus P2 omega 2 quantity over P1. That would be our optimal amount of x1. x2 star, 1/3 P1 omega 1 plus P2 omega 2 over P2. Okay? We could draw the picture, and we would do that as follows. Put x1 on this axis, x2 on this axis. Somewhere in the picture, we don't know the value of omega 1 and omega 2, but somewhere in the picture is our omega 1, omega 2. Without knowing what it is, we have to draw it somewhat arbitrarily. There's omega 1, omega 2. We know that the budget has to go through that, and we know that it's going to have the slope minus P1 over P2. And then when we maximize utility subject to the constraint of the budget, we're going to end up with some tangency, and they will either end up being a net buyer or a net seller of x1, and they'll be the opposite of that for x2. We could go ahead and fill in what we found last time for x1. So this would have been 2/3 P1 omega 1 plus P2 omega 2 over P1. And this, of course, would have been 1/3 P1 omega 1 plus P2 omega 2 over P2. Okay? What you should practice then is what's going to happen when the price changes of good 1. It's going to cause a rotation around the endowment point. So this is a case where P1 is falling. If we had a case of P1 rising, it would be getting steeper. Okay, so we could have falling, or we could have rising the price of P1. And then we're going to want to contemplate what the effects of that change in price are, okay? And we'll have to amend our understanding of income and substitution effects to do that.